In this topic, I'm going to talk about the ways that we can manipulate the metrics so that we can change the path to reach to one destination. And I'm going to give you an example here. I'm going to go from router 1 to router 2's loopback interface and see which path I'm going to choose, because I have two paths. The one that goes through router 3, it is a frame relay path, and the one that goes straight to router 2. So let's go and check this using topology table. If I check show IP Eigrp topology table, and I'm going to check this for 110.120/24. This is a 24-bit network ID. You can see that I have two different paths available, and the path that is preferred is the path with the lowest metric, and that is the path that has the 156,000 as its metric. The second path that goes through the serial interface has a metric over 2 million, so this is not going to be the preferred metric. So there are several ways to change this. I can decrease the metric of serial interface using decreasing the delay. For example, this is 45,000 microseconds of delay. I can decrease it. I can increase the bandwidth on this, and of course you know that the minimum bandwidth in the whole path is gonna be taken into consideration. And if I want to do this, I need to change the bandwidth on router 1 serial interface, on router 3 serial interface, and on router 2 serial interface. So this is a lot of configuration, and of course I may not have permission to do this on the other routers. So one nice way to change the metric is using offset list. For example, if I want to increase the metric of some path that is coming through fast 01, I can increase the metric, and this will be much higher than the current metric of the serial interface. And I'm going to do this right now. So let's go back to router 1 first and see the different options available. First of all, I want to go to interface fast 01, and I'm going to increase the delay to a very high value. You can see that this is the largest value available. I'm not going to use the largest value because it will make the route unreachable. I want to have the route reachable. I'm not going to lose it, so I make it about, for example, 1,000,000. It is going to be 10 million microseconds. I have entered 1 million of 10 microseconds. So this is the delay right now. So if I show interface fast 01 and include just the line that has DLY in capital, that's the delay, you can see that the delay is a very high value. So let's check the topology table. Show IP/Eigrp topology now for 110.120/24 will tell me that now my serial interface is the preferred interface because it has a metric of 2 million, but the metric that I have on fast 01 is about 25 million. It is much higher, and now it is not preferred. So increasing the delay is a good way to change the metric, but it may affect other processes other than Eigrp. If I have some other process that takes delay into consideration, it will break that process. So I prefer not to do this. Changing the bandwidth has the same effect, but again, it may have side effects on other processes. So I'm not going to use this kind of manipulation. So I type in no delay 1 million, and I'm going to do this. I go to router Eigrp 100. This is the AS number of router Eigrp, and I'm going to add an offset list. Offset list adds a value to metric, so the metric is going to be much higher. So offset list, it asks me the access list that I have created previously. I haven't created any access list. If I assign 0, this means every route or everything that is will be included in this access list. I'm going to add an access list with the name, with the for example 21. So I haven't created access list 21. I'm going to create this. Now let's see what I'm going to add. I'm going to have this route inbound, so whenever it comes in, I'm going to add some value to that. And what is that value is gonna be? I'm going to add this about, for example, 5 million. So this is 5 million, and now it tells me which interface do you mean. If it enters, for example, fast01, I mean to add 5 million to this, so I include fast01. If I do not include any interface here, every interface is gonna be included in this offset list. So if this route comes from the serial interface, it will be added this much of metric. So I hit enter. Now I'm going to create the access list 21. So I exit. Access list 21 is going to permit only one route. So it is host, or it is, no, this is the network. So I had 110, 1, 2, 0, and 255, 255, 255, 0 is the network mask. And an implicit deny is in the end of any access list, so I'm not going to do anything else. So let's check the metric again. So I'm going to check the show IP Eigrp route, and now you can see that again I have 5 million added to the metric that fast Ethernet 01 is going to report. So the actual metric was 156,000. Now because I added 5 million to this value, you can see that it is 5,156,000. So this is a good manipulation. I say that I am telling the router iOS that add this much to the metric that is going through fast01, and I'm not going to use this route anymore.